Hi, today's lesson is on 9.3b, reference angles. And so there's this new definition called a reference angle. And we're going to let theta be an angle in standard position. And the reference angle for theta is going to become an acute angle, right? So you notice in the previous section that we now are talking about drawing angles or sketching angles anywhere on this quadrant of not just being like a small triangle in the right. Okay, so now I've got triangles in quadrant 2, in quadrant 3, in quadrant 4, but how did I draw those triangles and use the correct, what we didn't know is that we needed to know something called a reference angle. And so the reference angle is the right triangle that we draw using the x-axis going to either up or down to the end of the terminal side. Okay, so it's really basically what's happening is that I'm going to draw a line down, up, right, or up. And whatever it is, I'm drawing this vertical line to create a triangle, and the reference angle is always the angle inside the triangle there, between the x-axis and that angle. Okay, so it's in a different spot every single time. And they were only addressing quadrant 2, 3, and 4 here because if it's in quadrant 1, it's pretty clear what angle that is. And so there are these formulas that can help you. In this one, we know it's going to be 180 minus whatever your angle is, right? Because these two will add up to 180. Or you can think of it as like pi minus whatever your angle is, if we're thinking in radians. This one, since we're going past 180, we know it's just 180, like that angle, whatever that big one is, subtracting the top part, right? So if I subtract that top angle, it's theta minus 180, which is theta minus pi, because pi and 180 are the same. And then here we have all the way around, which is 360 minus theta. This is all a little bit like, I don't like to memorize these. That's 4 different formulas you have to memorize. But notice that you're either subtracting or adding 180 or 360. So how do we know when to do what? Well, if we draw a sketch, then that'll help us figure out what's going on, right? So let's take a moment and sketch in 130, which we know is going to go past 90, and we're going to go past it by 40 degrees, right? So this is 40. Oops, that's a horrible. Let's try that one more time. I'm going to erase the 40 also. Okay. So this whole thing is 130, right? I know the whole thing is 180. So if I go 180 minus 130, then I know that that's my remaining angle, which is this one right here. That's my reference angle. Okay, because remember we're drawing our the last leg of the triangle straight up or straight down. So my reference angle equals to 50 degrees. 5 pi over 3 is a little trickier. We might not be good at thinking about like pi over 3 yet. But I want you guys, instead of converting this to degrees, let's take a moment and think about how can we think in fraction form, okay? So this is really the same as 5 times pi over 3. Would you guys agree? So if my entire top, like this whole thing, 180 degrees, is equal to pi, so here's 0, here's pi, that means I could technically divide into 3. So this would be pi over 3, right? And then this one would be pi over 3, and this would be pi over 3. And if I have 5 of them, what I'm doing is I'm dividing right? So there's a third here, another 2/3, 3/3, 4/3, 5/3. So really what I'm doing is going 1/3, 2/3, 3/3, sorry, 1, 2, 3 on top. This is the second one, right? Here's the third one right here, fourth one, and then fifth one right here. So that goes to here. 6 over 3 would be 2 pi, which is all the way around. Okay, so that's my angle. And then if I want to draw a reference angle, I need to figure out going straight up to the x-axis. And my reference angle is whatever angle is closest or touching the x-axis. You guys see that? Well, if I'm going pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, this last piece is also a pi over 3, right? So this is reference angle of theta is pi over 3. If you're having trouble seeing that, you could memorize that, hey, we're in quadrant 4 and we're going to take 2 pi minus theta. So you could do 2 pi minus 5 pi over 3. That's 6 pi over 3 minus 5 pi over 3, which gives you pi over 3. Okay. Let's do another one. Negative 310. So I'm going in the negative direction. 90, 180, 270. 270 to 310 is 40 more. So I need to figure out what this missing angle is, because I'm going to draw straight down. Here's my triangle. This is my reference angle. Well, if the whole thing is 360, then this right here, I'll draw it on the left. Theta equals 360 degrees minus 310, which is 50 degrees. Okay, reference angles are always positive, so we're not worrying about direction. Okay, last one. Okay, so this is 27 pi over 10s. We're going in the negative direction. Okay, so if it's pi over 10, the whole top from here to here is 1 pi. So how many pi over 10s do I have? I have 20 of them, so that's 10 pi over 10, 20 pi over 10, and then I have to go 7 more this way. So I have to divide this into 10 pieces. So that's going to be 5 here. And 5 here. Does that make sense? Right? So I'll have each of them be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And so I'm going to go all the way around. I'm going negative, so it's going to go negative. Oh, I should have drawn it on the other side. Negative 10 over 10, which is 1 pi. Negative 2 pi. And then I have to go 7 more pieces. Well, 5 of them will be here, and then I'll go 2 more here. And so the question is, how much is this triangle left? Well, if I went to, this part was 7 pi, right? So I did 5 total, and then I did 2 more pieces. That means there's my theta reference angle is 3 pi over 10. Okay. We'll do more practice in class. Okay. So now let's talk about trig functions. Okay. We're going to use these trig functions to evaluate for any angle theta. And so the first step is to always find the reference angle. We're going to evaluate the trig function for theta, the reference angle, and then we're going to check the sign of the quadrant function, because each one will have a positive, negative. Okay, so let's see what we're going to do. I'm actually going to start with cosine, because I think this one is the easiest, so I should have reordered it. So let's do this. We're going to sketch first, always. Cosine of negative 210, so let's go negative 90, negative 180. Minus 180 is like 30 more, right? So I'm going to go minus 180, and then I'll do 30 more. And if I draw my triangle down, I know that my reference angle is a 30, 60, 90 triangle. Okay. And so if this is the case, then I know that my unit circle, this is 1, this is 1/2, and this is root 3 over 2. And this is x, y. But since I'm going to the left, it's going to be negative x, positive y going up, right? It's like this is my final point. If I start here, I go left negative root 3 over 2, and I go up 1/2. Well, if you remember, cosine is my x's, so all I have to do now is take this x value, and you know that it's negative root 3 over 2. Let's check it just to make sure that this works. Ready? So we're in degrees right now. Let's do a quick check. We can do cosine of negative 210, okay, which is that decimal right now. And let's just do a quick check of negative root 3 close parentheses divided by 2. You see how that matches? Right? But I don't want decimal values. I definitely only want exact values. Okay? So let's do another one. Cosecant. This is the reciprocal of sine. And sine is my y, so it's going to be 1 over y. Okay? So let's do a quick picture just to see what it is we're doing here, so we can find out where our reference angle is. 17 pi over 6. Well, 18 pi over 6 is 3 pi. So I know I'm 1 pi over 6 away from 3 pi. So if I have 3 pi, here's 1 pi, here's 2 pi, here's 3 pi. And I'm very close, but I'm not quite there yet. So this reference angle equals to pi over 6. Well, it might be helpful to know what angle that is. I know what it is, but you might not know yet. So let's convert it to degrees just to see. So I'm going to multiply and cancel out our pi's, top and bottom, times 180. And 180 divided by 6 is 30 degrees. Well, that's another 30, 60, 90 triangle, right? So I have 30, I have 60, I have 90, so this is 1/2. It's the same exact one as this one, right? Negative root 3 over 2, and this is 1. So 1 over y, which is 1/2, is the same as 2, right? Because it's a reciprocal of 1/2. Okay. Let's do tangent, and then we'll move on to one last secant. Tangent of negative 240. We know tangent is y over x. So once you draw your triangle, your angle, make sure you go negative, which is down. So I'm going to negative 180. I'm going to minus 180 and see how much that is. So that's going to be another 60 degrees. So I'm going to go 60 degrees past. So if I went 60 degrees past that line, that means I have a 60 degree angle here, which is a 30, 60, 90 triangle still. So this is 1/2, but it's negative. And this is positive root 3 over 2. And so we'll have y, which is root 3 over 2 over negative 1/2, right? Y over x, which is equal to root 3 over negative 1, negative root 3. Okay, last one. Secant is 11 pi over 4, which is 11 times pi over 4. Okay, so secant is 1 over cosine. Which is the same, let's not do cosine x, let's just do cosine theta, which is 1 over x for cosine. That's why I didn't want to put x there, just in case. And then let's draw, hang on one second. Okay, so let's draw our angle. And there's going to be pi over 4, and there's going to be 11 of them. So there's 4 on top, 4 more down here, for a total of 8, and then I have to go 3 more. So that's like right here. 1, 2, 3. Well, if that's the triangle, and it's exactly in quarters, then it's 180 divided by 4, right? If you weren't sure about that, we can convert to degrees to see. So this converts to, see, divide by pi, multiply by 180 degrees, which is 11 times 180 divided by 4. Oh, I'm so sorry. Which is 495. Well, we're going to subtract 360 just to see what it really is. And so that's 135 degrees. Okay, let's keep subtracting. We know we want a total of 180, so 180 minus 135 equals 45 degrees. Okay, eventually you guys will get really good at just seeing these, but right now we know this is a 45, 45, 90 triangle. So what is our x? Because that's what we need. Well, we know it's going in the negative direction, and it's just root 2 over 2. And so if we know that we need the reciprocal of x, that's 2 over root 2, it'll be negative. That'll be 2 root 2 over 2, which is negative root 2. Okay? Okay, so how can we use this in real life? Well, if we talk about a projectile and a horizontal distance traveled by a projectile launched at an angle theta with an initial speed v, right? Here's our formula, and I have to give you this. It says estimate the horizontal distance traveled by a golf ball that is hit at an angle of 50 degrees with an initial speed of 105. Well, guys, all we're really doing is plugging in, right? So we know that we have horizontal distance is d equals, v is velocity, so, or speed, so that's 105 squared over 32 times sine 2 theta, but 2 times 50 degrees. Okay. And so what we can do is estimate this value by plugging in our numbers and seeing what we get. So let's go 105 squared, 11025 times 32 times sine of 100 degrees. So it'll be 315 sine of 100. That'll be approximately 310 feet. Okay. Notice this one we can't use exact values because we're given a non-special right triangle angle. Okay. Actually, I'm not sure why this problem is in here because this is totally different than what we were just doing. If it was, say, like an angle of 60, that would be much more helpful, right? So like, let's change it to, I don't know, 45. Someone jumping at an angle of 60 degrees doesn't make sense, right? So if this was 45, and then we can plug everything in there. So then we have 27 feet per second squared over 32 times sine of 2 times 45 degrees, which is 27 squared, 32 times sine of 90 degrees. Well, guys, sine is our y value, right? And our y value at 90 degrees is 1. So that'll be equal to 729 over 32 times 1, which is just 729 divided by 32. Ooh, it's a fraction or it's a decimal. But since we're talking about distance, we do need that decimal value, so it'll be approximately 22.8 feet. Okay. Hopefully this all makes sense. We'll practice more in class tomorrow.